Good evening, everyone, and welcome to the July 8th, 2011 meeting of the Royal Astronomical Society, the Ottawa Centre. Could I just get a show of hands quickly? How many people here have come to this meeting for the first time tonight? I knew Attila would have his hand up. Yes, okay. For those who really haven't been here before, this is a perennial joke. You might have guessed by now. Nevertheless, if there are any people here who are here for the first time, welcome to the meeting. We're always glad to welcome new people to come in. We don't require you to be a member in order to attend. You can carry on coming here every month as long as you like, although we'll probably make a case or a pitch to you at one point or another about why you should join the society. So stand by for that message somewhere a little further down the road. Anyway.
Sylvie.
Oh dear, oh dear. Okay. So without further ado, I guess we'll get underway. Next, please. Tonight's program. So Sylvie will be bringing us the 10-minute astronomy news. I'm sure that I know at least one item that's going to turn up in there, but we'll see. She'll be up in a moment. Rob Dick will be giving us a brief, note I say brief, update on national programs. Simon Hanmer is back. Very pleased to see Simon back. Last year, Simon was awarded the award for the best presentation for the year. We haven't seen him at all this year, so I'm very pleased to see him back, and he's got what I find a very interesting presentation to do. After the break, Rolf Meyer will continue his series outlining his activities while he was down south a couple of months ago, followed by our observations. And lastly, Eric Kuyala has got something about crater exploration that's been happening recently. I think Chuck's been in on that, if I remember correctly. So I think without further ado, I won't try and regale you with my skills or anything. We'll go straight over to RASC members in the news. So lately we've been getting occasional reports of our members appearing in media, and this time it is Glenn Ledrew. Glenn Ledrew produced this column in the most recent issue of Sky News. So those of you who haven't taken a look at it yet, I urge you to do so. It's a very interesting article, and we're, of course, very proud of our members who get that kind of exposure both for themselves and for the Centre. So, Glenn, congratulations. Well done. Okay, and now, without further ado, Sylvie Letourneau.
Is that here really for me? Okay, that goes well with my talk. This is a little model of the space shuttle, and it cranks. Oh, this is cool. Okay, let's start with a few tidbits for the Astro News this month. I have, unfortunately, some not so good news. The U.S. House of Appropriations Committee released its 2012 Commerce, Justice, and Science Bill, and they plan to cut NASA's budget by $1.6 billion US for next year, so compared to last year. And there are very explicit cuts to the entire James Webb Space Telescope project, which is said to be billions of dollars over budget and plagued by poor management. I won't say no more. Let's go to the next one. Oh, sorry, no, that's not the next one. Another bad news is the Astronomy Park in Pontiac. If you were here during the month of May's meeting, we had Stefan who came and presented this project to build a Astronomy Park in Pontiac. He was coming to explain to us how he was participating in a contest by Pepsi called Refresh Everything, where you have to go on the Pepsi website every day and vote for his project, and the most popular ones will win in their categories. Stefan was running for $100,000 in education. The deadline was June 30th, and Stefan's ranked 53rd in his category. So for now, there's no money. But I have a few words here from Stefan, who couldn't make it tonight, and he said he would like to thank the entire RASC Ottawa group for their moral support, ideas, voting, and encouragements. I did not win. In terms of ranking, we came 53rd out of almost 90 entries, which is about half. So Stefan has also commented on his idea of that this has given him publicity and exposure, and that in all cannot be a bad thing. He's still on the project, but I'm not sure exactly how he's going to reorient himself now. Next, could have been a bad news, but the asteroid missed us, so that's not bad. Phew. I had nothing to do with it, no. So it was the size of about a school bus, and it came much closer to the moon than the moon at about 12,000 kilometers from Earth at a speed of 100,000 kilometers per hour. So what it said is if it had hit us, it would have been quite a nice small explosion and a decent-sized crater for Chuck to visit. But, sorry, Chuck, close, but no crater. Oh, well. Next one, next time. It said it might even come back. It seems to be on a trajectory that it might loop around and come back, so maybe next time. Just raise your hand and wave, you know. So, last little astrobit news here is the launch of the space shuttle, the STS-135 Atlantis. Last shuttle launch was today and successful at 11:26 a.m. I saw it live from my computer, but Mike Mogalam was there and on Cocoa Beach, Florida, and he saw it, and he will have an awesome video for us next time, plus more of his experience. But in the meantime, here are a few words from him. He was absolutely amazed. There was a long column of moving flame that was visible from his observing site that was 20 kilometers away. The shuttle appeared from behind the building in a distance, and the beach crowd went crazy. Aren't people always crazy on the beach? Maybe it's just me. Anyway, everybody was screaming, clapping, jumping up and down, and then he quoted that there was a woman beside him in tears. I'm just wondering, was he talking about his wife and he didn't want to tell us it was his wife? But I don't know. We'll ask him later. Anyway, he was really surprised how quickly the shuttle moved. He said that lasted about 30 seconds, and then the shuttle entered the clouds. And that's the way it appeared, too, on the website. When you looked at the cameras from the ground, you could see the shuttle go and then eventually disappeared in the cloud. But then you got the cameras on the shuttle, and then you can see a little more if you're on the internet. But for him, that was it. But then 60 to 90 seconds later, he heard the rumble of the shuttle. And he said, I could literally feel it, and it lasted a good minute. It was an amazing an experience that he will never forget. So, so that's all good, but as you know, we just said that's the last launch. So I went on the web and just looked at answering the question of where are these shuttles going now? So it seems that they have been relocated. Enterprise is going to be going, Enterprise never went to space, but it's been built, so it's going to go somewhere. It's going to the Intrepid Sea and Air Space Museum in New York City. The Smithsonian National Air and Space Museum in Virginia is getting Discovery. Endeavour is going to be moved to California Science Center in Los Angeles. And Atlantis is the last shuttle that just was launched today. It's going to stay in Florida. So that's it for the space shuttle. And what is? Oh, sorry, I'm giving maybe something away here. So let's move on to some more juicy, fun stuff. So the meaty science news this month is what's happening at the edge of our solar system. So while most scientists wonder what's at the edge of the universe and beyond, Voyager is telling us what's at the edge of our own solar system, and it's quite interesting in itself. So you don't have to go very far in astronomical terms to be amazed. Before I present this little topic with the help of a NASA video, I'd like to point out that thanks to Simon, I did some research, and yes, it is this year has been declared by NASA the Year of the Solar System, so the YSS. But since it's a NASA initiative only, I haven't heard much about it anywhere else, but hey, nevertheless, we amateur and professional astronomers, we can take this as an opportunity to spend more time discovering the solar system a little further and learn more of its mystery. So this one, from Voyager, what's happening is it's reached the edge of the heliosphere, and it's reported some data that has puzzled most scientists until now, and they came up with an explication of what that could be. So before I start, here is a little picture from Wikipedia, which, by the way, what I'm presenting now was published on June 9th, and Wikipedia is already updated with the new the new findings. So that's the pointer. So the Voyagers are basically at the edge past where the heliosphere is. So we're talking 100 astronomical units away. And so what they're found, so that's just, oh, by the way, do not get fooled. This is a logarithmic scale, so that's why Earth and Jupiter look like they're, Mars would be in the middle, but we're talking about this is 1 AU, and this is 100 AU, and then this is, 10 AU, and then 100 AU, then 1,000 AU. So everything has been compressed that way. So if we moved on, this is the old view of looking at what happens at the edge of the heliosphere. And people thought that everything was very smooth, but it seems that there are bubbles that will have some very interesting effects on all the cosmic rays and particles coming in towards the solar system. So I have to explain all this better than me. I should just go? Ah, voila. And do you want to start? It'll just go. It will just go.
The two Voyager spacecraft have been traveling away from Earth for more than 33 years, and they are finally in the outer edge of the solar system. This boundary is marked by the outer reaches of the Sun's magnetic field and solar wind, which form an enormous expanse called the heliosphere. As the solar wind travels out from the Sun, it pushes against the galactic medium and abruptly slows down. This is called the termination shock. Outside this is the heliosheath, where the solar wind slows to a stop, and the magnetic field is bent back by the ionized interstellar wind. The Sun's magnetic field spins opposite directions on the north and south poles, creating a sheet where the two spins meet. This sheet gently ripples as it travels outward, and the ripples get bigger as they go. When this sheet reaches the termination shock, it starts to compress, like water waves hitting a wall. The Voyager spacecraft have now found that after the termination shock, these stacked up ripples of magnetic field form bubbles, shown here as a computer simulation. This discovery has prompted a complete revision of what the heliosheath region looks like. The smooth, streamlined look is gone, replaced with a bubbly, frothy outer layer. This new layer also changes our understanding of how extremely fast-moving particles, called cosmic rays, enter our solar system. When they arrive at the bubble region, they slowly move from bubble to bubble until they can reach smooth magnetic field lines and follow them toward the Sun. The nature of the bubble region explains why Voyager 2 has been seeing variations in the number of energetic particles compared to Voyager 1. Because of its path, Voyager 2 has been passing in and out of the bubble region. When it is in the region, Voyager 2 sees many trapped cosmic rays and electrons. When it is out of the region, the spacecraft sees fewer. Even as the Voyagers answer questions about our solar system, they raise others. For example, scientists aren't clear yet how the bubbly heliosheath is linked to the ribbon feature discovered by Ibex and Cassini. This ribbon shows the emission of energetic particles and seems to indicate some interaction with interstellar space. In the meantime, the Voyager spacecraft continues sending back data, and, after 3 decades, they still have a unique perspective to offer about the universe we live in.
I couldn't have said it better myself. So the bubbles, just to point out that they are about 1 AU, so 1 Sun-Earth distance, so they're not small little things. And also, beside being cute, this understanding of how the structure of the sun's magnetic field is really will explain how the galactic cosmic rays enters our solar system and help define our own star, how it interacts with the rest of the galaxy. Now, one last thing, because I'm 2 minutes over. I'm wearing proudly my T-shirt, I need my space, but it's more I need my space shuttle and money, so maybe we should start collecting donation for NASA. Thank you very much.
Thank you. Well, Sylvia gave the game away when she talked to you about the year of the solar system. NASA has declared this. I believe that Mike Mogadon did actually mention it at one of these meetings from what I could see in Astronauts. But, you know, it's meant to range from October 2010, which means we're well into it, through to August 2012. But they don't seem to have told anybody about this. It is actually on their website if you dig around for it. But they really haven't worked very hard on this. Now, personally, from my point of view, you may have gathered this, every year is Year of the Solar System. But what I want to do this year, I want that nevertheless we mark the year of the solar system. And so over the next 12-month period, I've got a number of presentations on the solar system up my sleeve. I think you'll like some of them. Hope you'll like all of them. And I wanted to start this time around with this one, the late shrinking moon. How likely is it? You know, just when you think you've heard it all, some scientific team comes up with yet another, I'm afraid, wacko idea to claim their 15 minutes in the limelight. So I guess I should point over this way, should I? No, the wrong one. That's the laser. I'll get this right. There we go. Okay. Now, one of the more recent ones to catch my eye concerns the moon. Last August, there was an article published in the highly prestigious magazine, Science, which claimed that the moon, our moon, has shrunk at some time during the past 1 billion years. Now, when I read a scientific paper, I start by asking myself whether or not the fundamental premise of the paper makes scientific sense. If it doesn't, then I've got 2 choices. I can reject the paper from the outset, or I can continue reading in the expectation that the authors had better come up with some extraordinary evidence to support their extraordinary claims. So let's evaluate this late shrinking moon hypothesis against what we already know about solar system evolution. There we go. All right, now things shrink because they cool down, just like your telescope does at night as the night gets cooler, and so you have to adjust your focus as a consequence. So let's look at the heating and the cooling history of the moon. Now the solar system, as you now know, formed about 4.6 billion years ago, and the moon formed very shortly after that. The rocky planets and our rocky moon formed from the accretion of smaller particles and planetesimals, as they're called, whose motion, or kinetic energy, was transformed into heat. Now, in the case of the moon, we can still directly observe the relics of the magma ocean that formed by this heating, which progressively cooled and crystallized to form the white crust, which we see today forming the lunar highlands. Now, these highlands are white because they're principally composed of the low-density, light-colored mineral plagioclase feldspar, which floated to the top of this magma ocean just like scum on a pond. Now, all this happened in the first 100 million years or so of solar system history. Next slide, please, Chris. Now, between 3.8 billion and about 3 billion years ago, that's billion with a B, the Great Bombardment left major impact scars on all the rocky planets and the moon, including the Great Mare basins that filled with dark lava that erupted from the lunar interior. Now, given that most of these lavas are significantly younger than the impact basins themselves, these lavas were not produced by the impacts, and this is key. How were they produced? Rather, they formed as radioactive isotopes of elements such as uranium, thorium, and potassium broke down radioactively to lead and argon over time, thereby releasing further heat to melt the interior of the moon. And these lavas ceased to erupt in great volumes shortly after 3 billion or so years ago, and certainly by about 2.5 billion years ago. And there's no evidence for volcanic eruptions whatsoever during the past 1 billion years. So what does all this tell us about the moon? It tells us that the first half of the moon's history involved at least 2 episodes of heating, melting, and cooling. But most importantly, it tells us that by the halfway mark in the moon's lifetime, the moon had already cooled significantly. Therefore, if the moon was going to shrink because of cooling, you might expect that it would have done so in middle age, around about 2.5 billion years ago, rather than in its golden years, less than 1 billion years ago. So should we now reject the late shrinking moon hypothesis on the basis that the premise is false? Not yet. So there is a way to salvage it, and it's based on things called phase changes with cooling. Phase change with cooling is simply a change in the way that the atoms of a given composition rearrange themselves in a submicroscopic volume of space as temperature decreases. Now remember, this is physical change. The chemical composition of the material remains the same. Next slide, please, Chris. Now, you're all familiar with the phase change of water vapor, which is a gas phase, to water, which is a liquid phase, and then from water to ice, which is a solid phase. What happens during these phase changes from gas to solid is that the water molecules become more orderly in their arrangement, as you can see here. Next one, please, Chris. So what do you think happens to ice as it continues to cool to, say, minus 200 degrees Celsius? It shrinks as the water molecules rearrange themselves into tighter spatial arrangements. In other words, more mass in a smaller volume, which means a higher density. Well, the same thing can happen to minerals within a planetary body, except that the phase change there is also dependent on pressure. The simple example illustrated here, and it's a Mickey Mouse example, shows 8 atoms in a solid arranged at the corners of a submicroscopic cube, and that's on the left. With cooling, the atoms of the solid rearrange themselves such that a 9th atom is now stable at the center of the cube, and the cube now has a smaller volume and an increased density. Now, phase changes like this occur at specific temperatures and specific pressures. Can you think of an obvious example of phase changes like this that you know of from here on Earth?
Yes, steel.
Huh?
Steel.
Steel. Every woman, every married woman in the audience should be able to give me the answer. Diamond. Diamonds. Graphite converts to diamond through a phase change at the specific temperature and pressures that exist at depths of about 150 kilometers beneath the Earth's surface. So it's conceivable that the moon could shrink quite late in its cooling history if a mineral phase change of the kind I've just shown you actually occurred deep in its interior sometime in the last 1 billion years. However, and this is the big however, we have no evidence for any such phase change within the moon at all, and certainly not during the last 1 billion years. Even if it has occurred, it would be an extraordinary event. And as the saying goes, extraordinary hypotheses require extraordinary evidence. So if you stuck with me this far, let's now look at the evidence that the science paper presented in favor of the late moon shrinkage. And don't worry, it's all about surface observations. But you would need a gigantic telescope to do them. Next slide, please, Chris. The evidence presented to support the late shrinking moon hypothesis in the paper comprises visual observations of these wiggly scarps on the moon's surface. Now, here's a typical example. What have I done with the pointer? There we go. Here's the typical example. There's the scarp. And I draw your attention to 2 points. Firstly, the distribution of shadows shows that the sun is shining from the left, and this scarp is a relatively steep slope facing to the right. Secondly, the impact craters in this image are very small pockmark features. Look at these things. They're tiny. That's the biggest thing. And so that tells us that even without a scale bar in this image, this scarp segment is not very long, nor is it very high. Now, what exactly do lunar scarps like this one actually represent? They certainly do represent a local shortening or contraction of the lunar surface, and this is a function of how they grow. The first diagram on the right shows you the undisturbed lunar surface. Hit it again, please, Chris. Next, a near horizontal fault, this thing down here. It forms at some unspecified depth, meters to kilometers, beneath the lunar surface, and then it ramps up. It ramps up towards the lunar surface. Next one, please, Chris. There's something, as yet unspecified, but I will specify at the end of the talk, pushes the rocks that sit on top of the fault to the right, as the red arrow here indicates, pushing them like this, up the ramp and then onto the lunar surface. So even for a very small shortening of the lunar surface, and that shortening is indicated by this green arrow here, in other words, that's the amount of shortening we're dealing with. We're going from there to that there. Even for a small amount of shortening, we now have an asymmetrical topographic high with a steep scarp facing in the direction of motion. Now, this kind of feature is very common on Earth, where we call them thrust faults. Now, let's take a look at some of the other examples of lunar scarps used as evidence in the science paper. Next one, please, Chris. Let's start with the Lee-Lincoln Scarp in the southeastern corner of the Mare Serenitatis. This is the Mare Serenitatis here, and we're talking about somewhere down here. So where is this scarp? Well, here's a blow-up. This scarp is down here. There's that dashed line. That's the scarp itself there. And it's running between what are called the north and the south massifs. In other words, two hills, if you will, that bound a complicated-looking valley. This actually is the valley where Apollo 17, right there, that little white arrow, that's where Apollo 17 landed. Now, how big is this scarp? Next one, please, Chris. Well, here you can see scale bars, a scale bar in this image here, down there, which reads 1 kilometer. And that tells us that the scarp is pretty small and not that high. But I want you to notice how here you can actually see the trace of the scarp. It's wiggling. But notice how the northern part of the scarp here, it hugs the foot of the slope of this northern massif here. In other words, it hugs the foot of high ground. And remember this, because I'll come back to it in a minute. Next slide, please, Chris. Let's move to another scarp. This one's located on the far side this time, far side of the moon. The detailed image on the right, that's this here, that's this image here, is a blow-up of the southern part of the squiggly left-facing Mandelstam scarp in the other image. There's the scarp. And we've got this detail here is this entire image. Note the scale bars in both images. This is a pretty small feature. This scale bar down here is 3 kilometers. That one's 500 meters. The inset in the right-hand image, this one here, it shows a close-up of the scarp cutting across, right here, you can just see it, cutting across this small 20 to 40 meter across impact crater. You just see it cutting across there. Oh, and there's another cutoff actually right down there too on another one of these small craters. So we know, and this demonstrates that there has been some very minor movement. Next one, please, Chris. Now this is the Slitherscarp. This is the most spectacular scarp I could find among all the examples available on the web, and it's included in the science paper as well. The sun is shining from the left, and you have to admit that with its wiggles and its branches, it looks pretty impressive. By the way, this one's on the far side as well. Next slide, please, Chris. Trouble is, when you put it into context, within the Slipher crater, it's tiny. In fact, it's so small that I have to help you see where it is with this yellow arrow. And even with the yellow arrow, I still can't see the scarp itself. Okay, I'll come clean. This is the smallest scarp known, but the science paper did include it as evidence for a late shrinking moon. And by the way, there is a scale bar here. That's 20 kilometers. However, yet again, you notice how the scarp is close to high ground, represented by the Slipher crater wall. Again, I'll come back to this in just a second. Next one, please, Chris. The words at the bottom are telling you what I'm trying to tell you here. You all know what this is. You've seen one. You've all seen one at some time or another, though hopefully not in your lunchbox. When an apple's interior shrinks, its surface wrinkles, or forms scarps, if you will, at several scales to accommodate this shrinkage. You don't need a PhD to see that there are lots of uniformly distributed small wrinkles And it's uniform distribution that's the key thing. And there are a few large ones. I mean, these large ones here are pretty obvious, but look, it's wrinkled everywhere. So how does this compare with what we see on the moon? Next slide, please, Chris. Not so good. This is a map of the moon that places the near sides and the far sides in the same flat plane. Here's the near side, and this yellow stuff out here, and yellow and red out there, that's the far side being pulled around in this image. The black dots represent scarps that were already known before the science paper, and the white dots are the new scarps identified in the science paper. We've already seen that the scarps are not long, and here we see that their distribution is far from global and uniform. To be blunt, this looks nothing like our old dried-up apple of the previous slide. So from my perspective, things are not looking good for the late shrinking moon hypothesis, phase change or no phase change. Next one, please, Chris. So what do scarps look like on a rocky body that has really shrunk with decreasing temperature? You may remember several years ago, we discussed the scarps of Mercury. These are hundreds of kilometers in length, more than a kilometer high, and they're distributed all over the planetary surface. I don't have a scale bar on here, but these craters here, which are being cut by this scarp, these craters themselves are in the order of 20 to 40, at least, kilometers across. So we're in a different scale. Next one, please, Chris. And this image here of a single scarp on Mercury shows you just how big the shrinkage scarps of Mercury really are. Here's a part of Mercury. There's the horizon, give you an idea of what scale we're talking about. And this is one part of one scarp. Here's the scarp a little closer up. But you can see these are obviously a very different kettle of fish. Next one, please, Chris. So why does Mercury show such obvious surface evidence for internal shrinkage with cooling? Because as rocky planets go, frankly, it's weird. It has a disproportionately enormous metal core compared with standard planet formation theory, and still, despite MESSENGER, no one knows why. I'm hoping MESSENGER is actually going to give us a much better idea. But as the core cooled and shrank, it pulled the outer layers of the planet along with it and formed this amazing array of true shrinkage scarps, try saying that after a beer, that we see at the surface. Next one, please, Chris. So now you have all the evidence before you. Can you now answer the question I posed at the beginning of this talk? Have the authors of the science paper Yes, good. Have the authors of the science paper come up with some extraordinary evidence to support their extraordinary claim of a late shrinking moon? I would suggest that the answer is no. So now the onus is on me to explain their observations some other way. Fair enough. There's more than one way to feed a cat sour cream, and as a geologist, I know there's more than one way to create contraction or shortening features. It's all a question of scale. Let's go to the next slide, please, Chris. There we go. The moon is peppered with local topographic highs and lows. We just saw some of them. The outer parts of the topographic highs are commonly weak and they can slide, landslides. Remember how the lunar scarps are located fairly close to crater walls or to highland massifs? Material that slides down these topographic highs will tend to locally extend the lunar surface. Here, if this point here was originally up there and it's now slipped down, then I got that much local extension of the ground surface. But unless the moon is growing in size, something no one is suggesting here, nor have I heard anybody else suggest it, the lunar surface must locally contract or shorten somewhere else in order to accommodate this, as represented in this simplified diagram. So if this is sliding down slope here, and the material therefore bottoms out on this flat fault, which is below the surface, the white line is the old surface, and then ramps up the ramp here, then there is my shortening, represented by the green arrow, which is approximately the same as my local extension. Next one, please, Chris. So as you can see, I'm rejecting the late shrinking moon hypothesis because the fundamental premise the paper is based on makes no scientific sense. What do the authors have to say about the non-global distribution of their small scarps? Well, I quote, "Earlier populations of radial contraction probably resulted in other populations of small-scale thrust faults that are expected to be heavily degraded during and as yet unrecognized. Well, during the past 1 billion years, we're talking about micrometeorite bombardment, and I don't see how micrometeorite bombardment could efface an entire global array of these supposed shrinkage scarps. I have to tell you, this is one of the weakest scientific arguments I've seen in quite a while. I thank you for listening, and happy year of the solar system.
Questions? Thank you very much. Any questions?
I have a,
We have a few questions.
so I'd like to know if shrinkage was actually proven, would it destroy all our models of how the moon has affected the Earth?
No, no, because all we would have to be talking about a phase change. We know that within the Earth, for example, as the Earth has actually cooled over the 4.5 billion years of its life, we know that within the Earth, certain minerals which you might recognize, you might have seen in jewelers' stores, like garnet, for example, which is commonly used in costume jewelry. Garnet, as you go down into the Earth's interior, into the Earth's mantle, at around about 500-600 kilometers depth, it actually goes through a phase change and it shrinks. So it would be, it's only remarkable to actually be proposing something like this on the basis of the evidence I've shown you. If there was strong evidence that the moon had shrunk, and it was recent shrinkage, as in the last billion years, there are geological ways of accounting for it.
Does this affect your thoughts on Iapetus at all?
Does this?
Affect your thoughts on Iapetus?
Yes and no. We know that there are shrinkage fractures, shrinkage scarps, on the icy moons in the outer solar system. And we also know that there are at least 4 different phases of ice, and they're all related to pressure, and they're all related to shrinkage. As you go from phase 1, 2, 3, and 4, you're getting denser and denser and denser ice. And so one would in fact expect that these outer moons, made of ice, they have cooled over the last 4.5 billion years, and the reflection of that is the shrinkage cracks that we see on them. So, yes.
Go ahead. Hadley Rill near Apollo 15. Is it a crack in the surface or a scarp, or what is it exactly?
Hadley Rill is actually a bit of a squiggle. It's not straight. It's not as squiggly as some of the rills that you'll see on the moon. The really squiggly ones, they're formed by erosion. They're actually formed by lava rivers. The Hadley Rill, though, in its location right out on the edge of the Mare Imbrium, is most likely related, in fact, to the dropping down of the floor of the Mare. Once this huge thickness, about 12 kilometers, of iron-rich basalt had actually filled the original impact basin. But it's a somewhat squiggly version of these gravity-driven fractures. Paul?
Simon, I was going to ask you, I'm experienced in metallurgy rather than in the other rock type of stuff. You know that in heat treating, you got ferrite, and you suddenly cool it, it becomes martensite. That is, it's a phase change.
Yep.
Is it possible that during the age of the solar system, the sun was cooler at certain times, thereby cooling the thing down and cooling the whole of the solar system down, causing this change of phase due to heat, thermal? It's a thermal thing.
Yeah, I do indeed. But what one's got to look at is where is the concentration of metals. The concentration of metals in all of the rocky planets is in the core. There are metals distributed through the mantle and through the crust, but the real concentration is in the core. And what we do know from the seismic experiments which were left by the Apollo astronauts on the moon, we know that the moon's core is extremely small. Its metal core is extremely small. So it may well be going through these kinds of phase changes, but it is so deep down and so small compared to the rocky part of the moon, it could not account for surface shrinkage, as opposed to Mercury with this huge metal core, which basically entrained the entire crust, or let me rephrase that, the rocky outer part of Mercury, because we don't actually know what it is, was entrained in the shrinkage of the metal core.
So it's heat treating, or whatever you want to call
Yeah.
it. It's
Yeah.
a thermal thing.
Yeah. Remember, though, martensite is very special. Martensite, of course, can retain a memory. And I'm not aware of martensite being found actually in the natural environment. Oh, yes.
Yeah, so just for context, I'm Stephen. I'm Sylvie's IT department. Anyway, after such a wonderful and meticulous defrocking, if you will, of such an interesting proposal or hypothesis, I'm left with two interesting questions. One is, how can a journal allow something so poorly supported to be published? And I think that might be a trend. And number two is, how does, I'm sure you're not the only one, or it's likely you're not the only one to come to these conclusions. How does the community as a whole actually challenge these types of things in journals and try to improve the science that we're seeing these days?
What you're talking about here is the fundamental flaw in the whole concept of the peer review system. The peer review system for scientific papers runs into one enormous problem. There aren't enough people who actually have the specialist knowledge to cover all the papers that are being submitted to journals. And so what happens is you'll get an astronomer with a physics background who's sent a paper like this to review and reviews it and says, well, it doesn't look bad to me, whereas it should have gone to a geologist, planetary geologist or otherwise. And this isn't the only example. I mean, in my own field of specialization, I have had to write entire papers actually challenging what has come out in other papers. You've got to be a little careful about how you do it. You don't want to be sort of attacking the people. You want to be attacking the ideas. On the other hand, if one is going to actually put in what is called a formal comment, that's the normal way of doing it in the peer-reviewed literature, then you actually have to be a member of that field of science. You already know the examples, for example, with respect to climate change, where any other scientist who isn't actually branded as a climatologist, basically, is basically challenged if they try to challenge any of the science that's put forward. So it's really, you're putting your finger on an inherent issue within the whole peer review system. But as Churchill said about democracy, it was a terrible system, but it was the best one he could think of. And peer review is the same thing. It has its flaws, and these kinds of things get through.
Thank you very much, Simon.
Thank you.
Carrying on from there, our next presenter, Rolf Meyer, with interesting observatories of the Southwest. That's the southwest of North America, not of Ottawa.
So there's a lot of observatories in the Southwest, meaning like Arizona, New Mexico, Texas, California. And, you know, you can imagine that people who are amateur astronomers gravitate to that part of the continent because the skies are always very good there. And indeed, there are many observatories. You will drive along and every mountain peak or every what looks like a good observing site out away from the cities you see things that look like observatories, especially on the top of almost every mountain. And you know, there's the famous ones that people will report on when they come back, like Kitt Peak and Lowell Observatory. But I'm going to show some other observatories that people may not typically be aware of and visit. Now this is the area called Arizona Sky Village, and you can see already that there are quite a few houses there with domes. There's about 20 houses there now. Most of them have observatories, and at least half of them are domes. So in ASV, this is the dome of Rick Bino, and he built this actually on top of his house, and it's a homemade dome. And inside he has a 24-inch plane wave telescope, which is a fairly good size. This particular tube is an open tube type of construction, so to keep the optics clean, there's a cover that goes over top of it. There was a bit of a dust storm when we were there, and I think still a little bit of dust got in, but you have to pretty much cover all the optics on a design like this because it is totally open. Rick is a permanent resident there. This is another house at Arizona Sky Village, and this house is owned by Adam and Tracy Clayson. Now they are actually residents of North Bay, and they make several trips a year to Arizona Sky Village, and this is the house that they own. And the roll-off observatory that he has just behind the house. And it's a very large roll-off roof observatory, because inside he has a very large telescope. This is a 30-inch Dobsonian, and that's Adam there talking to Linda. And plus he's got plenty of room there for visitors, and I think he's planning to put in a few other telescopes as well. This particular design, he did some very clever things. There's along the edges, there's all around it is a material that I've never seen before, but it's kind of a brush material that keeps out the dust, so it stays fairly clean inside. So Arizona Sky Village is near the Chiricahua Mountains, and we enjoyed going for a number of hikes into the Chiricahuas. And sure enough, even within the Chiricahuas on various peaks, even though it's a national monument, there are people who have managed to build observatories on them. And you know, you can see them off in the distance. There's, what is that, on top of a peak, and there you can see it there. So there's one of the observatories. So we'll just zoom in a bit, and there it is. And there's another one. It's not even quite on a peak.
Rolf, did they build the roads too to get up there?
Yeah, well, so this is the thing, right? So this is like in the middle of nowhere, and it's a fairly steep peak. So you can see here, yeah, he had to build a road. So you know, I mean, we talked about this to people who live around there, and yeah, people have run out of money building these. It's true. I think these were all several $1 million. The general feeling is that the people who built here exactly, you know, they had more money than they knew what to do with, because it's not a really good. It's not that much better a site than on the area below the peaks, and much less accessible. And yeah, it's tough. So it's a it's a problem. And most of the expense is, you're right, is in building the road, especially since it's actually largely on public land. So, well, this is a little more reasonable. This is Granite Gap in New Mexico, and I showed this actually a couple of months ago. This is a series of roll-off roof observatories that they're building there for people to rent out. And I think you can buy one of these either on a timeshare basis or permanently, and keep your telescope in it when you come down for your vacation or whatever. And I think they're planning to build quite a few of these. The sky is pretty good there. Actually, not too far away, also in New Mexico, is Clyde Tombaugh's 16-inch telescope. This is not the one that he discovered Pluto with, but this is the one that he had in his own personal backyard when he lived in Las Cruces. So they basically took the whole thing, and this is what it looked like in his backyard in Las Cruces. Again, it's an open tube design. It's a 16-inch, I think, f8 maybe, fairly long focus. It was built probably in the 40s and 50s, you know, using fairly old technology and stuff that he found around out of scrap metal and whatnot. It has a clock drive, which is actually a clock drive. I think it's a weight-driven clock drive, but it's a really neat telescope, and it's excellent optically. But it just sits out there in the open like it has for the last 60 years or so. Not in this location, but this is what it has always looked like. And also in that area, I also showed this. This was a series of remote-controlled observatories, and there's about a dozen here. They were apparently built by a group in Newfoundland who hoped to rent out time on these, and inside are computer-controlled remote telescopes. And I'm not sure how successful they were, and I don't even think they're all fully occupied with optics. But but it's a fairly ambitious project that they have going. But I think, you know, there are many challenges in having a remote-controlled observatory, and this, you know, they're not there to maintain them, and we have enough trouble with a smart scope where we have access to it. This is going to be really difficult for them, I think. This is an educational observatory at the base of Mount Graham, run by the Eastern Arizona College, Discovery Park campus. Unfortunately, this was on a holiday weekend in February, I guess their President's Day, so we couldn't go in. But it's an educational facility, and I think they have quite a few displays in there, as well as this observatory. So this is at the base of Mount Graham, and this is a view of Mount Graham itself. We didn't go up Mount Graham, pretty long drive, and it's fairly remote. So there's a telescope right on top there. I think there's a few observatories on top, but the one that you can see here is the one that houses the large binocular telescope, which you may have seen in the press. And that's as close as we got to it. This is the Trinity site where the first atomic bomb was exploded. So the bomb itself was exploded somewhere down there at the end of this road. So we couldn't go much further than that. It's actually open twice a year, but not the day that we were there. So where are the observatories? So there's some observatories there, and there's a view of them. There's a close-up. Now, I don't think these are astronomical observatories, even though they look like it. I think these were used to observe nuclear explosions, because this was an area that they used for testing nuclear explosions for a while. But curiously, all the domes are pointing in the same direction. So I'm not exactly sure what they still use them for. If they, maybe it's you know, still a military area. Then maybe these are used for astronomy now, or maybe I'm mistaken about what they were used for. But I don't know what they're used for. Does anybody know?
Any of these.
Richard, you know?
And near-Earth asteroids. That's possible.
Well, I don't know. I don't think this is the linear, if that's what you're thinking of. Yeah, there is a. I don't know. I don't think this is it. Does anybody know?
Possible that they would be optical theodolites for tracking aircraft.
Yeah. So there's 1, 2, 3, 4, 5, at least 7 of them that I can see. Anyway, a mystery. Okay, this is actually a middle school near Tucson. Now, you know, there's actually still a lot of money in America, and I don't know. I suppose they have some large percentage of the population unemployed, but there's also still a very large percentage of the population that's working, and there's a you know, certain part of the population that has a lot of money, and this particular community in Tucson is fairly wealthy, and they've obviously got enough money to build an observatory. So this was one night when they had a star night, and not only did they have their telescope out, but a number of people brought telescopes, and they had, you know, the kids from the local high school came out and did some observing. They actually had a program for the kids associated with this observatory. So is this an observatory? Well, it looks like an observatory, but it doesn't look like it's covered up. So does the telescope just sit out there? No, this is actually pretty neat. So this is the telescope, and it actually rolls into that building that you see there on those rails. So it's got a very sturdy base that the telescope will sit on, and when they roll it out, they screw it down into its locating pins, and it's quite solid. But when it's not in use, it's rolled back into that building that you see there, and there's actually a number of portable telescopes in there as well. They store in there for the kids to use.
So no problem keeping the snow off the rails?
No. I've been in Tucson 1 or 2 times when it snowed, actually, in January. They do get snow, but that's not a problem. Okay, this is the city of Tombstone welcomes you to the legendary Boot Hill Graveyard. Okay, so Tombstone is in this part of Arizona where there's numerous astronomy clubs in this area because it is so good, and people who are interested in astronomy do gravitate to that area. But what's this with Boot Hill Graveyard? Well, okay, so there we are in the graveyard, and you can see the cross. The crosses marking the actual graves, but you can see the observatory, right? You all spotted the observatory. So this was pretty amazing to see this here. So there it is, an observatory just beside Boot Hill Graveyard in Tombstone. And just behind here, oops, actually I'll go back here. So just back here is where the shootout at the OK Corral took place. Okay, so this is Sedona, Arizona, which you may have heard about. And so this is a pretty typical view. Actually, there's a lot of pictures like this that people have taken because this is such a amazing view. So here is this $30 million mansion among mere $1 million mansions in Sedona. So, okay, but there it is, and it's just very bizarre to see this.
Looks like a rusted bell there, right in the picture.
A what?
Is that a rusted bell in the picture on the left side?
The rock formation.
Oh yeah, the rock.
Oh, it's a rock.
Are you referring to this?
Yeah. What is
Okay,
that?
so this is actually a view. It's not shown here, but this is actually taken from a church called the Chapel of the Holy Cross, and it's built into the side of the mountain. It's kind of a Frank Lloyd Wright thing. So that's what people are there mostly to see, okay, is this church built into the side of a mountain, because there's like tons of people here, which are not shown in this, but when they go up there, what do they see? They see this. So, and I think this popped up maybe 10 years ago, because it wasn't there before. So there it is. It's quite amazing. And okay, so what's the story here? How did he even manage to get a building permit for this? I don't know. Like this is in downtown Sedona. So it's okay. So it's $30 million. No, I don't believe it's for sale, but this was the price tag. So the story is, as far as I can determine, talking to people locally and what I found on the internet, this is a Romanian inventor who apparently worked on a lot of medical technology, and he has a lot of patents on medical devices, and that's where he got the money, I guess. So it's certainly an enviable looking thing. And there's the dome. It looks very nice, but of course, I mean, technically it's all wrong, right? I mean, you've got the heat from the rising up from the house, and you've got a dark dome. Domes are supposed to be white to reflect the heat, but it sure looks neat.
More money than brain.
So, oh yeah, okay. So this is also in Sedona, and yeah. So there's actually an astronomy club in Sedona. They're called the Sirius Lookers. Isn't that funny? It's spelled Sirius, like the star. And so they do have observing sessions. This is not part of it, but okay. So we went in here because this was so intriguing, because this is Sedona is kind of a touristy place. So there's a lot of stores, tourist-related stores, and this is kind of like one of them. But there is a telescope, as you can see, sitting in the yard, and a sign on the shop that says telescopes, and yet it's called the Mystic Earth Galleria. Okay, so what's that all about? So we went in, and sure enough, they have Mystic Earth Galleria, and then they have another room where they sell telescopes. Meads and Celestrons and whatever. I mean, really, you know, good quality amateur telescopes. So that's what it is. He does these paintings that, you know, that include constellations. Very, very good paintings that sell for quite good money, and he's also got this telescope. And we talked to him for a while, and yeah, he's quite interested in astronomy as well. And one thing that he did inform us was that you know, this is an area that relies on the natural look of the region and the rocks, and they want to preserve all that. And so part of that is that at night, really, they don't have street lights, so they have, you know, just enough lighting so that you can see the shops and hotels and restaurants that you want to go to, but there's no street lighting as such. But unfortunately, there's a move by the state to acquire the highway, and then the first thing that they would do is put up lights to light up the highway, because right now it's being maintained and owned by the city. So they're trying to put a stop to that. So if we can ever do anything to help with that, I suppose. Oh, that's it. And oh, you can't read it. It says Alien Recovery Team on the truck there. So yeah, this was also in Sedona.
I think he's parked illegal.
Yeah. Unfortunately, the store that this was associated with wasn't open. We wanted to go in and see what they had, but it looked pretty cool anyway. Okay, that's it.
Good. Thank you, Will. And we'll probably call Rolf back up in a couple of minutes because it's time for the observation reports for tonight. So tonight's observations, as you can see, Paul commissioned Mike Earl, Bob Olson, Rolf, and Paul Cloninger. So to start off with, you don't need a mic, do you?
No, I don't.
I knew that.
This is IC 1296. It's about, a matter of 4.2 minutes northwest of M57. The M57 is burnt out because I have a 14-inch scope, and this thing was exposed for 15 minutes. So M57 is very bright, you see. But the other one, the other item is a magnitude of 14.8. So I thought at this time of the year, when everybody's looking at M57, this thing is only, as I said, about 4.2 minutes of arc away. So if you have a large field of view, or if you're taking a picture, this could easily be seen. This is it's a spiral, a barred spiral type of galaxy. It's only about a minute by half a minute, so it's quite small. You'll probably have to have an exposure of at least about 5 minutes anyway on an 8-inch or a 10-inch telescope. But it's a nice thing, and many people are not aware of it being right there so close to M57. Next, please. Oh, this is just a little group of galaxies that I took that are in Lacerta. Lacerta is just east of Cygnus. The middle one there, that's IC 1441. It's a spiral of 15.5. The other two on the left is NGC 7242, and on the right is IC 5191. This is an interesting group because in the summertime, when you're looking at these, of course, are the distance there, I think, is enough that if you have a large field of view and a large telescope, it's about 4 minutes. 3.3 on the right and 4 minutes on the left, so you'll be able to see them. So these are things, as I said to you one time, I show you things that are sort of off the beaten path, out of the way. You know, people don't usually look at these. They're not beautiful pictures, they're not eye candy, but these are things that you'll find rare to see them because they're not published often magazines or these groups of galaxies and things like that that are out of the way. But this is what I'm interested in. So this is a group that you'll be able to see quite well with say an 8 or a 10-inch telescope in Lacerta, which is just at this time of the year is just east of Cygnus. Thank you.
Thank you, Paul. Next up, an observation sent in by Mike Earl. As you can all read, I guess I won't have to tell you what that is. When he sent it in, he said he was rather surprised to have been able to get this. He had thought that it would be very difficult because, of course, it's way deep in the south. And he reports now that he has been able to track and photograph it, that he's able to observe it with binoculars as well. So it might be an interesting object for you to try and match his performance, see if you can see it. That's the Hubble telescope. Yep. Sorry, I thought you read the...
We were looking at the moving picture and missed the words.
Ah, I see. Okay, yeah, the Hubble. So...
Well, we thought it was taken by the Hubble.
No. That natural mistake, though. I could see how you could do that.
See how
Anyway.
the trees are moving with it? Yeah. See how the trees get sucked along?
Yeah, that's right. It's the speed. That's what does it. Yeah, the
I read a
speed.
scientific paper to explain that.
That would be it. Yeah. Pretty impressive, though, eh? Mike also reports that he's rapidly approaching his most current goal. You might remember about a year ago, I guess, he presented on, I can't remember the number, but in the thousands of satellites that he was trying to track. His most current goal now is 4,000, and apparently he's approaching that fairly quickly. So we can probably expect to hear back from Mike sometime in the next few months. Anyway, next up, Bob Olson. Is Bob here? Yep. Good. Come on up, Bob.
Last meeting on January 3rd, I went home and somebody posted that there was a supernova in M51. So I rushed outside to see if it was clear, and it was clear, so I dragged my telescope out, and it clouded over. So then the next clear day from June 3rd was June 14th, so I dragged my telescope out, and I had a camera failure. My heater and my cooler in my camera failed. And if my cooler and the camera is not cooling the chip off, I get 32 times as much noise in the chip. So the pictures were unusable. And so finally on June 18th, I got a picture of the supernova. And just to help you with that, this is a picture on June 18. And there's a picture not on June. Notice the satellite going through, by the way, or the asteroid. So I'll just click back and forth. That's a much higher resolution picture, by the way. I just cropped it in to give you the view. And just in case you're missing it, all right? All right? That's the supernova. That was taken in April. That was in 2009, and that's in this June 18. A couple of things I should tell you about this is that this is a Type 2 supernova. It's an explosion of a single massive star whose core has collapsed. The Hubble has actually identified the star. They went back and looked at it, and the Hubble has enough resolution to actually pick out the star, and it's a yellow supergiant with a mass of about 18 to 24 suns. And M50, just a sort of a side note here, M51 is about 23 million light years away. So what you're looking at is something that blew up 23 million years ago. And so I was taking a course down in Rochester, and the teacher was a religious right guy from Chicago. And I was showing him this picture, 23 million year old supernova, and he assured me that I had to be wrong because the universe had been created 7,000 years ago. And he was dead serious. All right. I'm kicking through starry night, which is how I do my observing. I look at starry night on what is in the sky right now, and I saw this thing called elephant trunk, and so I pushed the button, and my telescope went to the elephant trunk, and I took this 2 or 3 minute picture, And
That's a great shot.
yeah, this wasn't 2 or 3 minutes, by the way. But I couldn't. You know, what the hell was the elephant trunk in there? I didn't know what I was actually photographing, and so I took several hours of images, and then I processed it, and then I had to go and find out what was the elephant trunk. And the elephant trunk is this part right here. So, you know, I was kind of thinking it was down, like my telescope would point at the elephant trunk, but it was just in the upper corner. And what that is the shock wave by some massive star blasting that gas out of the way. And this thing here is the shock wave that you're seeing. Sometimes they call those cometary nebula. It looks like a comet kind of is going. And the elephant trunk, I'm assuming, is this thing right here. It kind of looks like the curve of an elephant trunk. And that would appear maybe faintly glowing in a large telescope, a large visual telescope. And in there, as this gas gets crushed by the star, and I'm guessing it's this one, but I don't really know, what happens is you start getting stars formed in here. And that one there is one of the stars that's actually being formed. And so you get these low mass stars being formed. Okay.
Bob, did you have some pixels drop out on the left there? That's a dark nebula.
Right here? Whoops, sorry.
Dark nebula there? That's probably a
You're talking about right here? No. Yeah, and I want to tell you, when I processed this part to look good, that went absolutely black. I had to reprocess it all to make it so it was more gray than black. As I mean, it actually is not really black. Okay, thank you.
Okay, so last month I showed a picture just past 28 hours past the solar eclipse, and then 2 weeks later there was a lunar eclipse, and just a few days ago there was another solar eclipse. No results from the solar eclipse, but this is just 2 hours after the total lunar eclipse of June 15th, which unfortunately again was not visible in the Western Hemisphere. It was all an Eastern Hemisphere event. Okay, so this is going to be a video of the Milky Way Rising. So something to watch for in this. Well, I guess we'll look at this a couple of times. So.
Rising? There's a song called that.
So unfortunately, it was cut short by the clouds. So watch at the beginning. The house and the flag are basically lit up by just 4 candles, which I blew out at the beginning. Lots of clouds moving through. The odd time there will be a firefly, and let's see if we can run it through again, Chris. And so their fireflies are wavy green streaks, and of course there's lots of airplanes. So run it one more time, I guess. So airplanes are straight lines, and the fireflies are wavy lines.
Are you sure?
Yes. Okay, this is the rotation of the Milky Way. You can see the Big Dipper on the left and a little bit of the Milky Way on the right. Again, you can see fireflies periodically.
Looks like you caught a meteorite there, didn't you?
No, these would be, it's an airplane.
It is, eh?
Oh yeah, if you take a picture and you get a streak, 99% it's either an airplane or a satellite. Very rare to get meteors, except on shower nights. Okay, and finally another one going from twilight to dark, and there's a lot of stuff going on in this one. So I'll show you. So okay, so what you should watch for is down here will be fireflies. Of course, lots of airplanes in the sky. This is the road along here, so you'll see cars going by periodically. For a few minutes, which is just like less than a second. And the whole scene will be lit up by a yard light, which is on a motion sensor, so some animal may have walked through. Yeah, so let's run through that. Lots of airplanes.
Where did you shoot these from, Ralph?
Oh, just the front yard.
Very nice.
You can see some of the fireflies there. And it seems like just can't get away from clouds moving through. But they sort of make it cool, I guess.
Welcome to Ottawa.
The Dark Horse Nebula is showing up really nicely. Can you point that out on the way?
Oh, I don't know what that is. What's the Dark Horse Nebula?
Galactic Horse.
What's that? What's the Dark Horse Nebula?
Right in the middle. Stop. You stop it right there. Stop right there.
Oh, we can't stop
The
it.
body of the horse, the head, the two legs.
Okay. Okay. Oh yeah, and it's let's see. These are this is the lights from Almont, and
Oh, it's right in your south.
yeah, it's right in the south. Well, it's not that big. It's not that big in it.
Ralph, is each frame just a single image, or did you do processing in each image and then stitch them together to, you know what I mean?
I don't know exactly what you mean, but these are 30-second exposures,
Okay.
and I guess there's about, and I did it. This is about 2 hours, I guess.
Okay.
So, whatever that works out to, I don't know exactly. Yeah, sorry, I did do some color balance on them, but I just did that as a batch process. I just did one image and then you just batch process the rest the same way.
Thank you, Ralph.
Hi again, everybody. Just a bit of a departure from my usual stuff. I'm a promo man tonight. I just wanted to let you know that there's currently at the Cube Gallery down on Wellington Avenue. There's an art exhibit going on called Nuit Noir. I've left some brochures here, and essentially what the owner Don Monet has done here is he's asked a group of artists and astrophotographers to submit works to the gallery, and he's got a month-long display, including talks on Rob Dick actually gave a talk last night on light pollution, and Al Scott will be giving a talk in 2 weeks on I think it's black holes and the search for modern search for extraterrestrial life. So coupled with that, we've got art exhibits there. There's about 5 contributors, including myself, from the center, and we also did some sidewalk observing. So we had telescopes out on Wellington Street with all the lights and everything, and but it turned out really cool. Actually, we got nice views of the moon and Saturn last night, and a lot of people and a lot of interest. So we've got some good stuff down there. Sanjeev has got stuff down there. I've got a number of pieces, which is what I'm going to show you tonight. Tony Peterson, John Wayne Ross, and Janet Tulloch is also one of the contributing members. But there's all sorts of mixed media there. It's not all just astrophotography. There's sculptures and there's painting. So if you're interested, check it out. It's about 5 blocks west of Parkdale on Wellington, and it's called the Cube Gallery. So as I said, I left some stuff out in the front there for you. So I just thought I'd show you quickly the four pieces that I've got on display there. This one I've actually shown you before a few months ago. This is what I decided to do for the exhibit was do a bit of mix of astrophotography and a little bit of fanciful space art as well. So this is a straight astrophotography shot that I took of the Pleiades back in November with an 80mm Apo and Rebel XT, and it's one of my favorites that I've done recently. So I thought I'd submit that one. The next one, please. Now that one, that was a lucky catch. 2 months ago, there was actually an auroral display here in Ottawa. It lasted for maybe at an hour at the most. I was out walking in the country that evening. It was mostly cloudy, and I was looking at some clouds in the north, and I just happened to notice there was a bit of a light pillar extending above the clouds, and I thought, oh my God, that looks like an aurora. So I went in, grabbed my gear, went to a nice spot there, and by the time I got everything set up, the clouds had cleared, and we got this auroral display here in Ottawa. So, yeah, as I say, it lasted about an hour, but even in the course of that hour, these bright pillars lasted only a few minutes. They would appear, and then they would sort of march along and then just dissolve, and that happened about 4 or 5 times there. So I was lucky. That was actually my first shot, and it turned out to be the best of the evening there. So we're hoping to see more auroras as the sun gets a bit more active, but that's the nicest catch I've been able to make in about the last 5 years, and certainly from the Ottawa area. Next one, please. So this one's a bit of space art. This is actually an historical recreation of the supernova event of 1054. It was interesting that Bob showed you that supernova in M51. Supernovas, as you probably all know, are some of the most massive explosions that occur in the universe. Certainly from Bob's image, you can see that the light of a single star blowing up can cross 23 million light years of space and still be a bright object to photograph. Well, in the year 1054 AD, something quite marvelous happened here on Earth. We saw a supernova, and by all accounts, it was so bright when it was first seen from Earth that it appeared as a bright multi-rayed star that was visible in the daytime sky for over 3 weeks. And by some estimates, its brightness rivaled that of the full moon. So it was a very, very bright object. It was seen as a bright star for about 2 years after that in the nighttime sky. And so what I did is I did a series of photographs. This is a montage of 7 different photographs that I took to recreate that event, to show you how it might have looked on the specific morning, July the 5th, 1054 AD. I chose that morning because you can see the little inserted image there of the pictograph. This is a work done by a Native American Anzazi Indian down in the Chaco Canyon of New Mexico, and it's believed to portray this event as he saw it in the dawn hours of July 5th in that year. So pretty cool event. This just to put things in perspective too. This object actually went on to form what we know today as the Crab Nebula. So this is the actually originator of the Crab Nebula, and if this event had occurred within a few dozen light years from Earth, as opposed to the 6,000 light years that it is away, we would probably not be here having this conversation tonight, because it probably would have ended most life on our planet. These are really, really powerful explosions. So anyway, that's just as I say, it's in historical reproduction where the stars and the moon and the simulated supernova are all astronomically correct. And being a science fiction fan, I couldn't resist the last one, which is this one. This is something I put together. Again, it's a photo montage of 6 different images. The Rosette Nebula itself. This is a sci-fi scenario depicting ruins discovered in the future on a planet that's much closer to the Rosette than we are. We're about 5,000 light years from the Rosette Nebula, and even from our distance here on Earth, the Rosette is a large object. It spans almost 3 times the diameter of the full moon, although it's very, very faint from our point of view. So if you picture yourself on a planet maybe 100 or 150 light years away from the Rosette, it would be a stunning bright object that would fill 40 or 50 degrees in your field of view. And so in this scenario, we've discovered some ancient ruins of a humanoid-like civilization on this planet. And again, in this scenario, the planet is now completely devoid of life. Its atmosphere has been stripped away, possibly by a supernova explosion from the nebula itself. So I had a lot of fun doing these, because it's a bit of a different slant from my pure astrophotography pursuits there. So it kind of merges the left side and the right side of my brain together.
That's fantastic. What did you do for the ruins?
The ruins are actually a recreation of bits and pieces. I was fortunate enough to travel to Greece and Egypt last year before all the strife occurred, and so they are various bits and pieces from my travels in Greece and Egypt. From some of the temples and the statues that are photographed there. And the foreground is actually from the Bryce Canyon in Utah. So I just sort of melded them all together to create this science fiction scenario. So I encourage you to go out, check it out. It's an interesting display. There were, I think, about 20 different artists that contributed to the display. And again, also Dr. Peter Watson will be talking on in 2 weeks along with Al Scott. So they're going to talk about the latest findings about black holes and our modern search for extraterrestrial life. And again, as I say, if the weather's permitting, we're also going to have an observing session there on the sidewalk at Wellington. So it was very cool. And there's a nice Bridgehead coffee shop just down the road from there. So it was a very enjoyable night last night. It was perfect temperature. The sky actually held for us, and people. I set up my 2U cam on an 8-inch Schmidt Cassegrain that the owner has. Actually, he's quite the astronomy aficionado himself, and we put on quite a show for all the passerbys there because we were looking at the moon, and you could see craters down to about 5 or 6 kilometers resolution. So people were going like, "I can't believe that's the moon." So that's very cool. We had a lot of fun. Thank you.
Thank you, Paul. Okay, and last up, Eric Kuila is ready to tell us about his most recent adventures.
Belated Happy Canada Day. On Tuesday, Chuck O'Dale and I went aerial exploring of a possible new crater site in Quebec, just 2 hours drive north of here, about 45 minutes by plane. We received this image of, it's a terrain image from Google Maps that someone sent, and we both jumped on it when we saw this because we realized this could be a site. Just because it's a circle doesn't mean it's an impact site, but we spent time studying the images and Google Earth and so on, and decided to take a little flight out to the area. So if we could go to the next slide, please. Chuck's always filling up the airplane, make sure we've got lots of fuel for our trip, and we embarked from Rockcliffe north on this flight. Next slide, please. And iconic image for us. We did take this image every time we go up in the plane. Next, please. On the way up, we had a chance to see a few other things, including my cottage. And this place here, if you'll recall last year, we had an earthquake. And just in northern Quebec, there was a farmer who lost his field, and it's still in that condition. And seeing it for real is quite something. I'd seen these images before, but when you see it yourself, it really brings it back. Next, please. So we headed to a place called Saint Verenick, Quebec. It's about 40 kilometers east of Mont-Laurier. And the town is actually within the crater, the supposed crater. Let's see, I can't tell. Okay, the slides are a little bit out of order here, but, and where's my pointer? Okay, here we go. So the crater would be, the rim would be these mountains here that we saw. We saw in the previous photograph, this is within the rim here. These lakes. Next slide, please. And here we found a spot that has bedrock. Now, bedrock is very difficult to find in this area. We saw mostly sand. Next slide, please. And okay, this would be the Trans-Canada, the 117 highway. And this is where the bedrock is. And there's a little trail here that goes up to the bedrock. And that's where we're planning a ground expedition to in a week from now. We'll be checking that out. Next slide, please. And there's another view of the bedrock. This is what we came to find from the air. It would have been impossible for us to see it from the ground. Driving around, we would have never seen this. So the aerial exploration is very useful that way. It helps you get a real feel for what's actually there. There is no map or anything that you can find image-wise that really tells you what's going on. Aerial exploration is the only way to really see what's there. Next slide, please. So this is the town of Saint Verenick here, and we're now heading towards the north end of the supposed crater. And as we flew around the site, we really felt we were in the presence of a crater. It's hard to explain, but and you can only see it with your eyes. The 3D effect of seeing something gives you that impression that you will not get in any photographs. Next slide, please. So again, we're exploring, trying to find bedrock, which we saw in the earlier photographs. Next. And again, you know, you see this would be the rim here, and over the horizon we see it again. So very positive feeling that this is a crater site. Feelings aren't science, so we have to find the real evidence, which is found in impact melt, shatter cones, or even breccia provides a clue that it's an impact site. And okay, I can't tell. Okay, this is at the northern rim. Again, this would be the rim here, and following back and around. And next slide. So we're doing a counterclockwise circle around the site, and always seeing signs of a rim as we go along. Next slide, please. And this is the road that goes right through the middle of the site. And we're happy that there's a lot of roads and access. And I can't think of another place where there could be a town in the middle of a crater. Does anyone know where there's a crater that has a town in it? Okay, well, no. Sudbury, sort of, but not really this kind of situation. Sudbury is very, very large, so I mean, it covers more than just that town. This is a town literally sunk into this crater, and I don't think anyone there knows that this could be an impact site. Next slide, please.
What diameter is it?
It's 8 kilometers in diameter, and it's about twice the size of Chubb, of the Pingueloit crater in northern Quebec. And next slide, please. Let's see. I can't tell what this is anymore. We recorded with video as well as taking these slides, and I do a color commentary as we're flying, so that we have notes. We're taking notes orally through this. It makes it a lot easier than looking down and writing on a piece of paper. Next slide, please. And there would be the town again, and now we're on the western edge of the rim. So we're seeing a rim again, almost all the way around this site. Next slide, please. And this is another shot of the bedrock that I took from another angle. Next slide, please. And there's the town. So we come in, the 117 is down here. We come into the town, and this view is probably one of the best ones that show that it's a rim in here. And like I said, in 3D, when you're looking at it out the airplane window, you really get a feel for that. Next slide, please. And a better shot of the town again. The middle of the site has a small lake called Bruno, so we've used the working name for this crater is the Bruno crater. So when we visit next week, we'll be exploring the bedrock and see if we can find some evidence. And I also want to go into the town and try to inquire if anyone has any information about it. Maybe the mayor's office or someone would know more about it. And next slide, please. And that's looking to the south, the town. There's not as much of a rim in this area to the south as there is to the north. But, and the bedrock would be somewhere in this area here off this photo. And next slide, please. And this gives a better indication where everything is. So we go up to Mont Laurier and then to St. Verenick in here. And this would be the crater site. And Chris, can we go to the next slide? Okay, this is really interesting because I have to take my hat off to Chris for giving me this photo, because we actually discovered there could be an actual double impact. So let's show the first. So this is where we think there's a crater in this area. And in other photographs, I had been looking around and thought I saw something in here, but until I saw this photograph, I realized this could be an impact crater as well in here, thanks to Chris. And so perhaps on a future exploration, we'll go by air and we'll check out this area and go back and look at this again. And I think that's it for the slides. Eh? Okay, so if wish us luck. We'll see what we can find, and if we do find something, we'll report it back to you. If we don't find something, we'll report it back to you, and we're gonna have fun doing it anyways. Thank you.
Go back to the microphone.
Sure.
Have you guys checked to see if there's a geological map of the area?
We've looked around, we can't find anything, Simon.
That area there must be a geological map.
We love whatever information anyone finds on this. Please just forward it to us.
It would be the first thing to check to see whether or not there's actually a geological feature, such as, for example, a granite intrusion, which would be that kind of size and shape.
Yeah.
We know the Bancroft-Halliburton area, for example, in Ontario, similar geology, in fact.
I wish I had Simon's insight into geology. That you know he can see things that we can't see, and it is very possible that these formations are just geological formations. I think Simon, you mentioned about plutons or something like that. Yeah, so it's it could be a fluke.
The thing to check is what they refer to in Quebec as the ministère.
Okay.
The ressources naturelles.
Yeah. Yeah, I could try in there.
Folks that have the maps for that area, and I'm pretty sure there is a map available.
Just bring Simon with you.
Did you see any sign of central uplift in the center?
No, it's so eroded that we didn't really see that. And it's you know, the if it is a crater, it's so worn down that it's near the end of its life. It's probably up to 250 million years old. And so I looked for that. Very sandy. And I tried to envision, you know, a fresh crater being eroded down to what it is now. But what we saw from the air was very convincing. We just have to find those rocks, the right kind of rocks. And that's the bell. Anything else? All right.
Very nice. Okay, so that pretty much wraps up the content for the meeting tonight. Just a few final closing points before we hit the road. First of all, our monthly feature, Estelle's Pick of the Month. Her choice for this month is publication by the RASC, which many of you may not have taken a look at. She has a copy in the library. Feel free to visit. I'm pretty sure it'll be open tonight, presuming they unlock the door. Go take a look at this. Very interesting publication. Next, please, Chris. Okay, so after the meeting, the usual, the library is open. Estelle? Yes? No? It probably is then. The Equipment Loan Library, as far as I know, Al is not here tonight. So that will not be available this evening. Coffee and conversation, as usual, will be available. Art and Fraser are taking care of that out in the lobby. I would remind you at this moment in time that the rest of the museum is off limits to us. It's closed for the evening, so please stay to the lobby area out front. If you need information about RASC membership, you can talk to Art Fraser. I don't think he's wearing his distinctive sweater this time of year, but nevertheless, he'll be out by the refreshment table. Okay, audience tonight, 89, which is way down, but then that's normal for this time of year. Everyone's heading off on vacation, doing other things this time of year. Many thanks to the organizers and speakers for tonight. Sylvie, Rob, Simon Hanmer, welcome back again. Rolf Meyer, Paul Commission, Mike Earl, Bob Olson, Paul Cloninger, and Eric Kuila. And thanks to our host, the Canadian Science and Technology Museum. If you have any comments or input on the meetings, you can send me email. My email address is at the bottom. It's not too hard to remember, bill.meeting.chair@gmail.com. Lots of dots in that. Next meeting, Friday, August 5th. So it is the first Friday of the month again next month, 8 p.m. as usual. Be there or be square. And I guess have a safe drive home. Thank you very much.